Just as a lead-in today, it seems as though the flow today is on quality and competency. And as a company, we manufacture all sorts of fire systems, but today what I'm going to give you is a really brief background on Nobel Fire Systems and why we're involved in kitchen fire suppression systems, but really why standards and approvals are important to us as a company, but also important to kitchen fire suppression systems as a product. So I'm going to run through a quick background on ourselves just to give you an overview of our understanding and so that you know where my background is and the experiences that we have as a company. I'll give you a quick look at the types of fire systems that are in the industry at the moment, and in particular the fire suppressant mediums that are at the forefront of fire protection, and then run through all of the current standards that we work to, but where are those standards going and what are we likely to see over the next couple of years that will influence manufacture and production of the equipment, but also the frequency with which fire systems are installed. So our background, my company, Nobel Fire Systems, used to be part of ICI, chemical industry, and our name, as Nobel suggests, it does go back to the Nobel Peace Prize and Sir Alfred Nobel. Our company used to be wrapped up in the chemical industry as a very small part of a chemical manufacturing process, and some of the technologies that we use in our kitchen fire suppression system, the airbag technology and solid pyrotechnics, we use today and we still continue to develop to get the best out of, to not just in kitchen fire suppression systems but all sorts of other systems such as explosion suppression and things like that. We're now as a company in our 16th independent year, but as a person my background is 30 years this year in the fire industry, and it makes me feel particularly old when I see 30 years flash up in front of me. As a company, kitchen fire suppression systems account for about 20 to 25% of what we do. So regulations, approvals and standards are part and parcel of what we're involved in every single day of our existence. And this just gives you an overview really of the types of systems that we're involved in. And it ranges from kitchen fire protection to offshore and marine, but also into petrochemical and energy production. So one day we can be working on kitchen systems and next we can be on a nuclear plant. So the experiences we have are far-ranging, and kitchen fire suppression systems, believe it or not, are one of the highest risks. They are one of the areas that fires happen more commonly than any other area. And the reason for that is because there still isn't any regulations around installation of kitchen fire suppression systems. So the types of fire suppression systems that currently available in kitchens can be split into two suppression mediums. One is wet chemical and the other is water mist. We manufacture both, but for the fire systems we put forward a wet chemical system. So, and the vast majority of the systems in the world are wet chemical. Why? There are a lot of different fire suppression system mediums out there, but this is aimed specifically at a type of risk, which is class F, which is oil fires, fat fires and grease fires. And these fires tend to burn a little hotter than normal hydrocarbon fuels. If we go to a petrochemical plant and we're protecting a bund area of diesel, petrol, they don't burn as at higher temperatures, so it's actually slightly easier to put the fires out, especially when they're bigger as well. But fats and greases are notorious for burning at high temperatures, which is typical of vegetable oils. They'll burn around 350 degrees C. So what you're faced with is a very intense fire from the start. And as a risk, it's one of the, I think, most difficult areas because the fats spread all the way through the kitchen from the cooking appliance right to roof level. So if we just have a quick look at the suppressant mediums themselves and why wet chemicals are used more predominantly than anything else. It's because there is a chemical reaction, and you're probably all aware of it now, that the reaction that we're looking for is saponification. We're actually looking to change the chemical properties of the oil and grease to a medium that won't burn. And every wet chemical system on the market, be it us, Ansell, Amrex, we all have the same process and similar sort of liquid. It's potassium based. And it's that chemical interaction we're looking at to knock the fire out very quickly. But secondary to that, what we've got to do is make sure that fire doesn't reignite. So the liquid that we spray onto the cooking appliances into that plenum is done as a mist, and that's there to start absorbing the temperature, to reduce that oil to below its reignition point. And what is very important is that, and it's an element that isn't specified often enough, is that the last element, and as basic firefighting goes, there's no longer a fire triangle, it's a fire tetrahedron, and what we're trying to do is attack every part of that to make it as efficient as we can and use the least amount of liquid as we can to extinguish the fire. We must interface to gas and electric shutdowns. If it's not done, then we're missing a critical element of fire protection. And it's one that we see very rarely happening when we go out to service systems and we see all of these systems being specified. They'll specify a fire suppression system, but not that it has to be interfaced. And this is where standards and approvals come in, which I'll talk about just in a couple of slides hence. Water mist is very, very good at putting out fires, but it doesn't have any other interaction with the burning medium other than cooling, and there is a little bit of secondary firefighting because as the water turns to steam, it actually produces an inert gas and reduces the oxygen level at the flame front. But its primary focus is in cooling. So as a water mist system, you have to supply water for longer to ensure that you reduce that temperature down so you don't get reignition. In fire protection, there are 3 levels within the standards that we apply to. A sprinkler system is classed as a fire containment system. Sprinkler systems actually aren't designed to extinguish fires, they're designed to contain. Then you get the middle, which is fire suppression, and the vast majority of systems that we do fall under that category of fire system, where their aim is to suppress the fire, it's to stop its growth, stop it getting any bigger, and halt it in its tracks. But there's no guarantees you can put the fire out because there's too many variables. Kitchen fire suppression systems fall into the third, which is fire extinguishment. Every fire system on the market has to be able to prove that they can extinguish a fire in every single cooking appliance that we're faced with in a kitchen environment. So you can loosely split the systems that are available on the market today into 2 categories. There's mechanical systems, which you're familiar with Ansell and Amrex system. Amrex latest systems being a hybrid of a combined electrical and mechanical. The outcome of the system and aim of every system on the market is exactly the same. That it's to detect a fire at its earliest time possible and suppress it by spraying a fire suppressant medium for a fixed length of time to extinguish the fire and maintain that fire in an out condition. Our system is slightly different than anybody else's, that it doesn't have any mechanical moving parts. And our system uses liquid exactly the same. We use a wet chemical liquid, and all of the detection is done via electrical means. So we tend to err towards UK and European standards on detection rather than US standards. So what are the current standards that we work to? I'm pretty sure that everybody will have heard of LPS 1223, and it's a UK standard written and administered by LPCB. And LPCB are an independent organisation, the British Research Establishment, that write and test products to make sure they conform to a specific set of criteria. Now, everything under these three standards have one thing in common. They're all pre-engineered systems. And what that means is that all the parameters for installation are pre-decided. These three standards are the only three standards that we have to be able to test to give you a marker in the sand of quality. These three standards set out fire test parameters. So within those three, there will be tests on fryers, tests on ranges, tests on salamander grills, canopy tests, ductwork tests, all those kind of things brought into, and they do differ quite a bit, and you will see as you get salespeople selling your fire systems that you will see all sorts of arguments in favour of UL as against LPS 1223, and likewise. My personal opinion is neither of them are that good. They don't go far enough. They concentrate on what you can see and what you can't see. And as we've seen now, there is a movement towards more duct cleaning, hygiene, and the reduction of the fire loading in the areas that allow a fire to transfer from the kitchen to roof level. So whilst these are really, really good and the only benchmark we have for testing, they're all as good or as bad as each other. So the current performance and testing standards, I'm walking about a bit, so they're all an independent assessment. So what you get isn't what we are telling you works, it's what an independent organisation has tested and underwritten to say, right, if you meet these standards, then you have a minimum level of performance that you expect. And every system that has one of these standards after its name, that certification, has been through the ringer to make sure that what you get at the end of it is what you expect to get, a fire extinguished. So the fire performance testing, but with that, there's also an element to those standards that test the equipment. So it's not just about fire performance, it's actually about longevity. And what they do within that is they will take other standards, or the British standards, European standards, in particular LPS 1223, and it'll test your hardware for its suitability and life safety and longevity. And those are three standards in particular, the EN3, that is the fire extinguishing standard, which will test the quality of cylinders. EM54 is a common standard on fire detection and alarm systems, so any electrical system has to conform to these standards, so that what you get, again, at the end of the day, is all the componentry within your fire system confirms some form of quality and longevity of service. So we also have in existence quite a number of different documents. You'll all be very familiar with DW172, which for me is one of the better documents that gives people a good overview of what fire systems you should conform to, what those elements should include, what kind of cooking equipment that it should cover, and the parameters that end users should be looking at to get a system that is one, value for money, and gives them a marker in the sand for their insurance companies to say, yeah, we're happy with the fire system that you fitted. But they're all guidance documents, none of them are mandatory. There's no regulations, there's no laws that say you have to have a fire system installed. There is in the US. Before you open a restaurant in the US, part of it is that you have to have a fire system fitted, or if it's already fitted, it has to be maintained and serviced to a particular standard. We don't get that in the UK. In parts of Europe, there are different standards. In Germany, it may come down to the fryer and the amount of oil it has in it, or the proximity of a single fryer to it. There's all sorts of complicated scenarios to consider on whether they will fit fire suppression or not. But what influences our decisions today? What influences the end users? And really, what there is a change to in the last 5 years in particular is that the responsibility for fire protection and fire risk assessments in workplaces has devolved from fire brigades onto managers of companies. So now there's an onus on people to carry out a fire risk assessment. In any property that has over 5 people, you have to have a written fire risk assessment, and part of that has got to identify these risks. So the risk of the kitchen is getting a higher priority within people's view. So some of that influences, I want to keep my business going. I can't afford to have a fire. Competition, I'll lose all my customers to them, so I've got to be protected and back up and running as fast as possible. Staff and customer protection is high on that agenda, and it's part of that workplace risk assessment. And then there's the financial protection. The part of what we've seen over the last 20 odd years is kitchen fire suppression systems used to be an option. It used to just be a tick in the box that everybody avoided because it was an extra complication. But as we've gone through the years, we've seen a gradual increase in influences from outside, be that fire service, be that from people that have experienced fire, but also the influence that you people put on specifications and tender documents that spell out to them it's an added responsibility, but it's also a critical business protection piece of equipment. They don't think twice about having to fit fire extinguishers. They don't think twice about having to put detection in. So it's moving into a phase now, is fire suppression in kitchens, into a more recognisable and regular format of delivery. I think somebody was just saying to me that probably when they're out there specifying systems, that 1 in 30 of their installations may include a fire suppression system. It's still fairly low down on the agenda. But if there's a fire, where does that responsibility come back to? You can't get away from the fact that it is the highest fire risk part of a building. If you're operating a hotel or a restaurant and you look around, you have fires in kitchens, and they happen every day. They happen very regularly. So that kind of influence is pushing people to fit fire systems more. But the biggest one for our industry, and it's the people that we work with day in, day out, is the insurance industry. It's their experience of fire loss that is driving installations, but it's also driving changes in standards and approvals. So where are we going to? And we had a nice little lead-in from Chris this morning on a new BAFE standard that was launched yesterday, SP 206. Now, there are all of these LPS 1223, UL, the ISO standards, there are all the guidance documents. But what does this give the end user? Why is it important for us as a manufacturer, and why is it important to our clients? This gives a stamp of approval on the company and organisation that is doing the installation. We can do the best testing in the world, but unless it is installed, maintained over its lifetime properly and competently, then it's not worth fitting it in the first instance. So what this tries to do is, drags in all of the approvals and standards, guidance documents, and on an annual basis we'll be audited. And as Chris was saying, there's a certification body that will come in and vet us, very much like you have your ISO standards vetted, and they will go through design manuals, certification. They go out on site and check your installations. They go out with your service engineers, and they also check and vet all of the distribution network that you appoint. So what we're looking to achieve is an end-to-end quality and competence mark of approval. So after that, and once you have the BAFE stamp of approval, what you're allowed to do then is issue a certificate from BAFE that will say categorically that the system, when it's been serviced and installed, conforms to all the regulations, so that it takes away all of the grey areas, all of the influences that salesperson may give you, and what it does is gives you a single level of competency. We've been very proud to sit on the working group over the last 18 months with Amarex, with ANSO, with BSI, with NSI and the other organisations that are invited into their LPCB to formulate experience that we have as manufacturers, and we have a lot of experience from fires. We did have a run, it's a good few years ago, that we had 1 fire per day down here in kitchens. We've probably got the best part of 5,000 plus systems installed in the UK now, but 1 a day is quite a lot. And that we're seeing a gradual decline from, because the influence that you have as quality in kitchen manufacture, quality of equipment, quality of maintenance, quality of hygiene and cleanliness is reducing the fire loads all the way. So we're inadvertently working together to provide a safer working environment for the people that are in there. So, future systems. The insurance companies have a big say in what goes on, and we will see that over this next probably 12 months to 2 years, the influence that BAFE will have in setting that competency level is going to grow in the eyes of the insurers. And we can see now they were involved in formulation of it in the working group, and they had part and parcel of what it should encompass, so that they're comfortable that at the end of the day, if somebody has a BAFE certificate, it's an easier path to get a fire certificate. And if fire service inspect, if there's a BAFE certificate, it will be recognised as a quality standard that encompasses all of the standards previously, which created the grey areas. So for us, it's in the last, I would say, 20 years of kitchen fire suppression system, it's a milestone. It's the start of another breath of fresh air into fire protection. So what are we going to see next? Where are we going to go to? Insurance losses say that the greatest area of fire loss is through fire spread. We get kitchen fire suppression systems on the cooking appliances, which is bread and butter. But to date, and this is where one of my bones of contentions with LPS and UL is, the last nozzle is at the entrance to the extract duct, and they kind of both ignore the building protection side of it. Every other fire system we do is based on a risk assessment, and we work from top to bottom of a risk. But because the standards don't go far enough to include other aspects of the building, that's where we say, oh, if it's Euro 300, it's great. If it's LPS, that's all we need. As a company, we want to drive it further. We want to work with insurance companies to reduce their losses, but also make sure that we got full building protection. Grenfell was a big fire, but what it did point out was that building regulations and the quality and competency of people that specify and design buildings aren't up to scratch. And what will happen, and there'll be some new legislation and standards come as a result of Grenfell, that it's coming all the way back down the line. They're looking for the people that specified or didn't specify a particular protection level. And if that's not done, then there will be consequences if there are fire losses, or even worse, there's a death as a result of it. So as a company, we want to see those standards increased, and as insurers, they want to see changes to how we install systems. So what will happen is we will see over the next couple of years a drive towards extended duct protection. We do our best at the moment within the standards that we've got, but I know in particular that some of the major insurers that take great ownership of the restaurant and hotelier industry are already pushing for this, and they're looking for things that they can hang their hat on that gives them that sense of security that when they underwrite a risk that they're not going to have substantial losses as a result. And BAFE goes a long, long way to getting that for them.